In this video, I'm going to share with you how I added breadboard ends to this table, as well as 3 big tips on how to avoid making the same mistakes I made when making it. So this table is the first project I've done for a new client that happens to be an interior design firm. I'm in the process of growing my business, and having a designer client is a big opportunity for me. I wanted to impress them by showing them that I could deliver great work on time for a reasonable price, so I really don't want to blow it by being too ambitious. So I suggested that they add breadboard ends to the table I was asked to make in order to make it more visually interesting. However, I haven't actually made breadboard ends before, but I've seen it done plenty of times on YouTube, so how hard can it be, right? Right? The design is fairly simple. A solid ash top with breadboard ends perched atop some pretty cool cast aluminum legs that are pretty convincingly iron. While I mill up the 8/4 ash boards I chose for the top, let's take a minute and talk about what some of you might be wondering. What are breadboard ends? Simply put, breadboard ends are boards that are attached to the ends of a solid wood panel, usually a tabletop, and usually using mortise and tenon joinery of some sort. The purpose of these boards is to resist the tendency of the panel to cup along its width over time as seasonal wood movement occurs. These can be installed using a variety of methods, from a traditional mortise and tenon joint to floating tenons, and several flavors in between. I'm going to be using the Haunched tenon method, and we'll talk more about what that means and how to do it later on. But before we get there, I'm going to finish rocking out while planning all these boards. Milling days aren't always the most fun part of a build, so to make up for that, I've made a habit of listening to rock music and playing air guitar whenever possible. Okay, I want to share the first tip I mentioned to help you avoid the mistakes that I made. When it was time to glue up the panel, I had planned to just glue together a couple of boards at a time, run each of these sub-panels through the planer, then glue the sub-panels up into the larger panel. However, for some idiot reason, probably because I was using Titebond 3 and thought, hey, it's got a longer open time, it'll be fine, I decided to just glue it up all at once. This was a big mistake. I had no plan for how I was going to lay everything out. None of my clamps were out and ready to go. I had already done 2 of the boards. It was just chaos. I broke the #1 rule of glue ups. Make a plan and stick to it. Once wood glue is exposed to air, it starts to set up. The timer's running. I was really pushing it with this one, and you can see me here starting to get a little bit frantic. I'm worrying about running out of time to get those tight joints that you always want when gluing up a panel. Thankfully, I managed to skim by at the last second and got all those clamps on there, and the panel really did turn out fine. But my point is, I could have saved myself a ton of stress by sticking to my plan. Okay, here I'm actually lying to you about the order in which I did these things. What I actually did next was square off the ends of the table and start cutting the tenons on the ends of the table, but you shouldn't do that. When making any mortise and tenon joint, you should pretty much always fit the tenon to the mortise, not the other way around. So I'm showing you these steps in the correct order. The next step when installing breadboard ends on a table is to make mortises in the breadboards. And what I'm working on is a jig to drill these mortises in the edge of the boards using my plunge router. But that process is a little technical, so I'm gonna let voiceover Cameron tell you about how we made that. Take it away, Cam.
Okay, the jig I'm making is fairly simple. It consists of a router base plate and 2 rails that run parallel to each other, which are held in place with 4 bolts. A hole in the middle allows the bit to pass through. I'll route a slot at each end to allow the rails to be installed. This will also give them room to adjust to various material widths. Since the bolts I have aren't long enough, I'll countersink them about halfway through the rails and widen this countersink to allow the elongated bolt head to sit neatly inside and not let the bolt spin around. Because this jig is fairly universal for doing this type of mortising and not a one-off for this project, I don't mind putting in some extra effort to make it nicer than I normally would. I did a test assembly to make sure things worked as expected so far, and now I can move on to drilling holes for the router to mount up. This is done easily enough by just tracing out the factory base plate onto the MDF. The biggest Forstner bit I have is good enough for the bit hole. I'll want to be able to see through it to locate the center of my workpiece, but it doesn't have to match the hole I traced. Using 3/4 MDF here also meant that I needed to countersink the mounting screws a little bit as well. To set up cutting the mortises, I just positioned the bit on my center line I had laid out and tightened the jig's rails into place. Now I can slide it all along the length of the workpiece without it moving from side to side. Since I only want to make mortises that are 4 inches wide, I made this little stop jig that extends past the end of the workpiece and stops the jig from moving past the end of where I want the mortise to run. It can be flipped over to work from both ends. For the inside stops, I just clamped a couple of scraps in place. I later swapped this out for just a clamp, which worked just as well. Okay, enough about this jig, back to Talking Head Cameron.
Thanks, Cam. With the jig done, I can use it to first cut the deeper 1 3/8 mortises for the longer tenons, and the 1/2 inch mortise that runs along the length of the breadboard end. Running the long mortise out to the end of the breadboard is a style choice, and it really isn't necessary. You can easily conceal it on each end by just cutting the long tenon short. In fact, this is my second tip to avoid my mistakes. I found showing this joint on the ends of the breadboard to be really challenging and time consuming to get right. And if I could do it over, I'd choose to conceal it by cutting the haunched tenon short and also leaving the groove 1 inch or so shy of the ends of the breadboard. So do what you want, but I'd say don't cut the groove all the way to the ends. So with the mortises all cut out on the breadboards, we can now turn our attention to the tenons on the ends of the table. The first step here is to square the ends off with a track saw. This first end went beautifully, but for some reason, cutting off the other end didn't go so well and caused a lot of burning. I suspect it's these track saw clamps I was using. I think they might have been causing an odd bow or bend in the track and not allowing the saw to ride square and level with the workpiece. I'm honestly really not sure. If you have a theory from what you see here, let me know in the comments. I really would love to get that figured out. But after I got that squared away, we could start cutting tenons. The approach here is to cut across the top to the 1/2 inch depth we need along the very back of the tenon, then make several more relief cuts toward the ends of the table, knock out the excess, and then trim it up with a router and chisels. To be honest, this was much easier said than done. I found it really hard to keep the router level using this track saw router guide, and ended up having to go back in several passes with my lovely little Stanley 71.5 router plane to trim it to fit. And this is my third tip. If I could do this all over again, I'd avoid this method entirely. I think my little track saw router jig allowed for some deflection and made the bottom of these cuts a little too sloppy. Instead, I'd make my initial track saw cut at the back of the tenon and then use the plunge router the whole time to hog out the bulk of the material. This would allow the router to register directly on the top of the table and cut exactly the correct depth on each pass. The next goal is to turn these two really big tenons into haunched tenons. So while I cut these by hand with my pull saw, let's talk about why this step is necessary. These breadboards are 4.5 inches wide. The mortises I cut are 1 3/8 inch deep. That's almost halfway through the tenon. If I had cut one really long mortise at 1/2 inch by 1 3/8 inches deep, that would leave two sides of this breadboard that are pretty flimsy, making it decorative maybe, but not likely to provide much support if this tabletop ever decides to cup. However, by only making the haunched part of the tenon 1/2 inch deep and making 3 longer tenons, we can both maintain the integrity of the breadboard and use the strength of its rigidity along its length to keep the panel flat. Next, we'll lock this in place with what's called Draw-bored Dowels. The basic idea of a draw bore is to use the strength of the long grain in a dowel to force the breadboard tightly in place against the tabletop without gluing it in place. But why not just glue it on? Well, if we were to just glue this whole breadboard onto the ends of this table, it would likely only take a couple seasons for something very bad to happen. See, since wood wants to expand and contract along the width of each board, we have to allow it to do that. If we didn't, it would try to do it anyway, even if that meant splitting itself apart. So to avoid that, we're only going to glue this in place on the middle tenon. This will allow the tabletop panel to expand out from its middle as much as it wants, and I've intentionally made each of these mortises wider than its corresponding tenon, and also cut the breadboards slightly longer than the overall width of the tabletop. So what I've been doing here is drilling holes to allow for some 1/2 inch dowels to pass through. Then we do a test install, mark the center of each hole on the breadboard, and then take it back off. To make this a draw bore, we carefully offset each of these holes 1/16 of an inch toward the middle of the tabletop and drill them out. Now, when we drive these dowels through, the dowel will travel through the top breadboard hole, around the tenon hole, and through the bottom breadboard hole. The tension created by the offset on these holes applies a force to the breadboard that pulls it in toward the table. And since we carefully only add glue to the breadboard side of these dowels, the panel is now free to move however it likes without possibly exploding on us. Okay, let's talk about legs. One thing I learned about making tables with metal legs is that it's pretty hard to visualize how it's going to look right side up when you're installing them with the table upside down. So when I was sizing up where to put these, I tried doing it just based on measurements. I looked up how much space someone sitting at the end of the table would need to be comfortable and put the legs that far back from the edge. Makes sense, right? Well, it would have made sense if this were a 10-foot long table, but it's a 7-foot long table. Instead, this is how it looked. So it obviously had to go back into the shop and get those moved into the correct place. It was a pain, but absolutely necessary to get those proportions right. And as it turns out, the designer let me know that the client didn't actually need to allow for seating at the ends after all. So bonus tip, ask as many questions as you can of your client and don't assume anything when doing custom work. My client's client was really looking for a table that was walnut colored. So for budget reasons, we used ash for the top, and I agreed to figure out how to make it look like walnut. So after a bunch of samples and back and forth with the designer, we came up with this dye stain from Transtin. And no, it's not their dark walnut stain, believe it or not. This is their coffee brown color, and I suspended it in water, which really helps reduce blotching, especially on big surface areas like this. It took a few coats to get it from its original blonde color to, well, this, but it works. And using a dye stain here still left us with the opportunity to top coat it with Osmo Polix. In my opinion, Osmo is really preferable to film finishes in terms of how it looks and feels. I wanted this top to feel like wood and yet still be really durable. And hard wax oils like Osmo are great for that. In my opinion, using polyurethane or lacquer leaves wood feeling more like plastic and a little less high-end. It's a lot more work to apply 2 to 3 coats of wax like this by hand, but I think it's worth it and it still offers a good amount of protection. It may not be the right choice if the table is going to take a lot of abuse, but honestly, even then, it might be fine as long as it's well maintained. So I think this leg placement is much better. I'm pleased with how the breadboards turned out, and honestly, I'm kind of impressed with how little the top looks like ash now. I mean, it probably wouldn't fool most woodworkers, but it might pass for most other audiences. Thanks for watching.